Yeah, so today is September the 7th. And today we will be upping it just a little bit. I'm going to scaffold this up for you. So yesterday we did simple one-step equations. They should have been pretty straightforward for you. Today we'll do two-step equations. Tomorrow, you guessed it, three-step equations. And what happens with three-steppers is the variables start to show up on both sides of the equal sign. So you'll notice that for today, all the variables are still just on one side. And that makes a big difference as to how we approach these. So these are specifically today called two-step equations. And they have a very sort of characteristic look about them. So as you would guess from the name, it's going to take you two operations to get these done. I tried to show you yesterday that all of those can be done literally in one step, every single one of them, one step. That could be multiplying by a fraction, dividing by 2, subtracting 9, whatever the case may be. Today's are going to require two steps. So for our first example, we have this. So right away, you notice something is a little bit different. I mean, yesterday's equation would have just said like negative 2x equals a number, and you would have divided by negative 2. A new player is in the game now. And so have you done this before? Do you know what order to do this in? There is a set rule about this, and I'm curious to know if you can tell me what it is. Zane? Yeah, that's I don't know. I teach based on what confuses me and doesn't confuse me. That's always kind of confused me, but that is correct. When you solve equations, you're doing the order of operations literally dead backwards. And so with the order of operations, you would think I have to multiply or divide and then add or subtract. With this, we have to actually add or subtract first and then multiply or divide. So if that makes sense to you, that's a great way to think about it. I try to think about equations, and this, what I'm about to tell you, will help you a lot in the coming week as these equations get harder and harder. You have one big primary goal here, and that is to get the variables onto one side of the equal sign and get the numbers on the other side. And you'll hear me say that a lot. I still have to address that with 11th and 12th graders, that like you're missing the big picture here. It's a separation, and the equal sign creates the separation. So the equal sign in the middle is the great barrier that says I have a left side over here and I have a right side over here. And our job is to separate. X's, pick a side, don't care which side. Numbers, you get the other side. So does it make sense in this case to move the 2x? No, because if I move the negative 2x, if I were to say add, I could add 2x to both sides, but then I'd be moving the 2x over to the other side, and he'd get there and be like, why'd you put me here? I have nobody to go with. And so what we're thinking here is the x's, they've gone ahead and laid claim to the left side of the equal sign. Said, that's my side. And so who has to move? 100% the negative 42. If you move the negative 20, what problem then do you encounter? You got nothing on the right side. And we want to avoid that until like March when we talk about quadratic equations. That's when we're going to start talking about setting equations equal to 0. But for the rest of this year, we want to keep some substance on either side. The only logical answer to what should I do is I should add 42 to both sides. And what comes of this is what I was talking about. You'll see here in a second that once we cross out our inverses and don't do the math yet, you drop down your negative 2x. You drop down your equal sign. And then you can worry about the arithmetic. What is negative 20 plus 42? It is positive 22. The idea, and I said this yesterday, is that white writing up at the top is called an equation. The blue writing is what we call a step, a transformation. You're doing something. And then the next white writing is the next equation that we're building. That's what a good equation solver does. You have something, you work a little bit, and you make a new one. And then you work a little bit, and you make a new one. And you do that as many times as you have to until you get to the one that says x equals a number. And now this ought to look familiar like yesterday's. There's only one thing logically left to do. What is it? Divide both sides by negative 2. and I'm going to cancel out my inverses. And again, before I do any mathematics, I'm going to build the next equation. Drop my x, drop my equals. The math can wait. Now I'm ready. What's negative 20, or excuse me, 22 divided by negative 2 is negative 11, and that's your solution. Okay. Good there? That's a very typical two-step equation. Here comes another one for you. 81 equals 9c plus 36. There is one very correct answer to this question and two very catastrophically incorrect answers. Who has to move? The 36. Specifically the 36, because again, we encounter that issue of if we decide to pick on the 81 and move him, we have left the left side with nothing on it. Don't put yourself in that position. The 9c has said, this is my side. I'm going to go ahead and inherit or take over the right side. So 36, hit the road. Make yourself gone. So I'm going to subtract 36 over here to make it go away, and I'm going to subtract 36 over here so that the math gods don't strike me down. Fair is fair. I'm going to cross off my inverses. I'm going to drop down my variable term. I'm going to drop down my equal sign. What is 81 minus 36? Indeed it is. The white thing at the top is an equation. The blue stuff is the work. The white thing then is the new equation. And now we work again. What do we do? Yes, on both sides of the equation, fair is fair. We cancel out our inverses. We drop our variable. C equals 5. Okay. I don't have a lot of these today. I think I have 3 more examples, and then it's your time after this. I feel like this is going to be something that if you just follow the rules, variables on one side, numbers on the other, you got this. It's easy. Next one. Negative 7 equals negative 15 plus y over 3. The variables have said, right side is mine. The y over 3 term has said, I am now the boss of the East Land. Right? So again, there is one answer that is correct. Who has to move? Specifically the negative 15. Wholeheartedly, the negative 15 has got to vacate the east side of the equal sign. So to get him out of there, I'm going to add a 15. Don't be fooled by the plus sign in front of the y over 3. That does not belong to the 15, right? The 15 is owned by the negative sign. The y over 3 is just a positive. I'm going to cross off my inverses. I'm not going to worry about what negative 7 plus 15 is. If I hope I can get this stuck in your head. Build your next line. There it is. There's my new equation. And now I got to do a little bit of math. What's negative 7 plus 15? Definitely positive 8. And just like we learned yesterday, now this is a one-step equation from here. How are we going to eliminate the 3? Yes, and we show multiplication, remember, with a set of parentheses like this. Monster brackets, some people, monster parentheses, just the whole equation gets encompassed. We're going to multiply by 3. We're going to multiply by 3. We're not worried about the math yet. We're not worried about the answer to the problem. We're worried about restructuring, and that is, let's cancel out our inverses. Let's drop our variable. Let's drop our equals. And now we can worry, what's 8 times 3? There you go. This next one that I'm going to show you is, in my humble opinion, the one that gets people the most. It doesn't even look like a two-step equation, quite frankly, but it is. There's got to be something about it that catches your eye. Like, I mean, as a math teacher, having taken thousands and thousands of marks of red ink over the years, I know the trouble. Do you see something odd, Brycey?
The X is like has like
It does. I tell you, if I can remember that, I'm going to go places, right? That what catches my eye and probably yours is that X is like, where's the number, right? We're used to seeing like 12 minus 5X or 12 minus 4X. And you're like, whoa, what's going on? So we have a couple of options for this, and I'll show you a couple different things. Option one is to think in the way that Bryce did. And that is to say, let's put a one there. I'm going to write it in red. Everything that doesn't look like it has a one in front of it does. One is the great invisible mathematical multiplier. This is not the way I personally do this, but this will work for you forever. Okay. Now, let's talk math. Who has to move? The 12. Yeah, there's just no doubt even about it. The 12 has got to go. And since it's a positive 12, ignore that. The minus is owning the X, not the 12. The 12 is positive, so we have to take away 12. A lot of times kids add 12 because they see that minus sign. They forget that, oh, no, that minus has nothing to do with the 12, dudes. We're going to cross off our inverses, and we're going to rebuild. We're going to drop down the negative 1x equals, and you got to know your math. What's negative 32 minus 12? Definitely negative 44. And now if we think in these terms that Bryce helped us out a lot by putting that invisible one in there, it's no different now than any other situation. It's just standard. How do we get rid of the negative one? You divide by negative one. That negative one is attached by times. It's a whole number. Well, it's called an integer, but it's like a whole number, right? It's not a fraction. And so I just divide by negative one. And I drop my x, and I drop my equals. And what's negative 44 divided by negative 1? Positive 44. What's that? And that's what I'm going to show you next. This method will work for you until the day you stop taking math classes. But I'm going to show you the way my brain interprets this. And there's even a shorter way than what I'm about to show you. But this way here, you can avoid the division at the end if you just kind of think in the way that Kyla just said, and that is, let's just talk negative. So first off, we're not going to change at the beginning. We're still going to take away 12. But notice I've elected to not assign a number in front of the x. It's still just what we call negative x. And this is where just common sense kicks in. And hundreds of times in your math career now will you encounter this situation where at the end of the problem, you're like, no one asked me to solve for negative x. So I just think logically, well, if negative x is negative 44, well, then I guess x is positive 44. You follow the logic? Right. And I have no issues with that. That last step, dividing by negative 1, if it helps you, do it that way. If you can think in terms of just switch the left, switch the right, more power to you. Okay. And I'm going to hold off on showing you the other way for now because I don't want to pile too much on your plate. But those are a couple of options when or if you encounter problems like that. Here's our last example, and then it's work time. Why don't you guys go ahead and try this one? I'll give you about 30 seconds. I won't get in your way. As you get answers, just raise your hand and tell me what you think. K equals whatever. And I'll put the answers on the board and we'll see who got it right. If everybody got it right, we'll figure that out. I'll be curious to see what you do. I know what you did in your first step. I know you all did the right thing. It's that second step, the final step. I'll be curious to see what attack you used, like what approach. Anybody got it? Zane? What do you think? Zane thinks that K is equal to negative 40. Brycey? You'll see, this is something I like to do, is that I like to go around the room and make sure that if you have an answer that's already on the board, you don't have to speak up. But if you get a different answer like Bryce did, I would like to hear from you. I'm not going to require that, but I like to sort of like, I use the analogy of like wringing out a washcloth in the shower. You know how you want to get all the water out? I kind of want to get all the answers out of this room, out of room 135. I want to see what anybody got. You got one of those red ones, bro? Okay. At this point, if you don't raise your hand, I assume you have one of the two red answers, right? Okay. This game is just this is mostly honestly for me to sort of learn about what you know, but it's also for you guys to sort of assess where we went wrong, right? You'll realize pretty quickly if you missed it, then you'll go, oh yeah, take mine off the board. Is this all of them? Are you? What have you done so far? So you've added 14 to both sides, I assume? Good.
Oh, okay, I see where I'm at.
Would you like me to take 72 off the board?
Yeah.
Okay. Did anybody else get 72? Because I don't want to destroy it rudely. All right, 72 has left the building. What's the first thing we have to do? So let's add 14 to both sides of the equal sign. Fair's fair. Cross off your inverses, drop down what we call the variable term, and that is negative k over 8. And drop down your equal sign. Does anyone else have negative 45? Okay, Bryce's answer has also left the building. It's shown itself the door. It looks like maybe we have a consensus here. What'd you get? Negative 40 seems to be the winner here. So with negative 14 out of the way, we now have a new equation that says negative k over 8 equals the answer to this basic math problem, which is 5. This was the step I was curious about. What do we have to do now to get k by himself? Good. And we don't want to multiply by 8. Why? You don't want to multiply by 8. Because that's going to, you can, but it's going to mean you have one more step to do after this. What could we do right now in one fell swoop just to say I'm done? Yeah, if I multiply by 8, then I haven't really finished the job. Because if I just multiply by 8, then I haven't killed off that negative sign. So by multiplying not just by 8, but by negative 8, now we have full cancellation. This entire negative 8 cancels this entire negative 8, leaving us with where we want to be. I hope that makes sense. Do you have to do it all at once? No, well, if you want to make it a 3-step equation, that's fine. It's totally fine. So now I'm ready. I'm going to bring down my k, I'm going to bring down my equals, and I'm going to pray I know my basic math. What's 5 times negative 8? That's that. Don't forget, you can always check your answers too. It's not, I used to make kids do this and make it worth points, and I just realized that, you know, can't make the horses drink the water, but you can lead them to it. You can always grade your own equations before, and that is by just taking the number that you claim is the answer and putting it back up in here and do the math. And if the left side and the right side equal each other, then you know that your answer is good. So I'm not going to require that of you, but you can always do it. Any questions? All right, your assignment is on Delta. It's due in about 23 hours and 30 minutes, so get her done. It posted itself, I think, about 20 minutes ago. If you did not get last night's done, you can also hopefully use the next half an hour to maybe work on both assignments and get them both done. That'd be cool.